Welcome to our channel Biswanka's Math Exclusive. Today I shall teach you what is integral equation and its type. Let's start. So this is the definition of integral equation. An integral equation is an equation in which an unknown function appears under one or more integral sign. That is hx yx equals to fx plus lambda a to b kxt ut dt, where a less than equals to x less than equals to b. Where fx, yx, ut are all unknown function, kxt kernel of integral and lambda is the parameter. It may be real or complex and not equals to 0, having same role of eigenvalue of linear algebra. Here's the types of integral equation. Integral equations are divided into two types: linear integral equation and non-linear integral equation. Linear integral equation are also divided into two types: Volterra integral equations, where bx equals to x, and Fröderm integral equation, where b is a constant. Volterra and Fröderm integral equations are divided into two types, first kind and second kind, and all the linear integral equations are divided into two types, homogeneous and non-homogeneous. Here are the definitions. Linear integral equations. A linear integral equation is called linear if only linear equations are performed in it upon the unknown function. Here are two examples: fx equals to integration 0 to x kxt yt dt, and yx equals to fx plus lambda integration a to b kxt yt dt. Non-linear integral equation. An integral equation which is not linear is known non-linear integral equations. Here are two examples. In first example, yx equals to integration a to b kxt ut whole square dt. It is Volterra integral equation. So when the upper limit of an integral equations, that is bx equals to x, then the integral equation is called Volterra integral equations. And when the upper limit is bx equals to b, then it's called Fröderm integral equations. Bx equals to x and bx equals to b. Integral equation of first kind, it is called first kind when hx equals to 0. All the format is same, only change some fx or some hx. Here hx equals to 0. It's called integral equation of first kind. Same Volterra integral equation and Fröderm integral equation are same as above, only change in the limit and hx equals to 0. Integral equation of second kind when hx equals to 1. First kind when hx equals to 0 and second kind when hx equals to 1. Fröderm and Volterra are same, only change in the limit and hx equals to 1. Now homogeneous integral equations. When we called it homogeneous integral equation, when fx equals to 0 and hx equals to 1. Fröderm and Volterra are same, only change in the limits. Here see the limits, and fx equals to 0, hx equals to 0. Non-homogeneous integral equation. When hx equals to 0 but fx not equals to 0, then it's called non-homogeneous integral equation. Fröderm and Volterra are same. Integral equation of third kind. When we call it third kind, when hx not equals to 0. Here we give a note that all second kind integral equations are also third kind. Why? When hx not equals to 0, it implies hx equals to 1, 2, and also when hx equals to 1, it's called second kind, and when hx equals to 2, 3, 4 and also 1, it also called third kind. That is, second kind is also called third kind, but third kind is not always true. That is, when hx equals to 2, it is third kind but not second kind. Singular integral equation. When we call it singular integral equation, when the limits are infinity or the kernel has a singularity. Here we see the kernel 1 by x minus t whole to the power alpha has a singularity. When we put t equals to x, then 1 by 0, that is infinite. It has a singularity. This type of integral equation are called singular integral equation. Now, today's end my topic. If you find my video is helpful for you, please like, share and comment. To have these types of video, please subscribe our channel and push the bell icon and select all to get notification for my every video. Thank you.